Good morning, friends, and welcome to today's lecture on the pacemaker and conducting tissues of heart. Now, heart, which is the central pumping organ of every organism, the blood circulation is generally conducted through this pumping organ, that is heart. But the mechanism behind continuous pumping of heart is due to presence of such pacemaker, or you can say conducting tissues, which are present in the wall of heart. Now, heart beats are regulated by nodal tissues which are present within the heart and the set of peripheral nerves which are coming from the brain. So due to coordination of these two things, the heart beats are regulated. The nodal tissues which are present, these represent the excitatory centers of the heart. So these are the excitatory centers which are excited by particular nerves. The first such nodal tissue which is present in the heart, that is SA node, which is also referred as sinoatrial node. SA node or sinoatrial node, which is located in the wall of right auricle near the opening of superior vena cava, that means precaval vein. So near the opening of precaval vein, this SA node, sinoatrial node, is present. The node is innervated by fibers which are coming from autonomous nervous system. The autonomous nervous system which uh, innervates this SA node in the heart. This node has an inherent power of generating a wave of contraction, and therefore it is called as pacemaker. So why this node, SA node, is called as pacemaker? Because it has an inherent power, because it has an internal power of generating a wave of contraction, and hence it is referred as pacemaker. This SA node establishes the basic rhythm at which the heart beats. So we know that our heart beats 72 to 75 times per minute. So this basic rhythm, this pace, this speed of beating of heart is regulated by this particular node, that is SA node. Hence it is called as pacemaker. Another such node which is present in the heart, that is called AV node. Now in the previous diagram, we have seen that where SA node is present. Look at this. Here is the SA node which is present in the wall of right auricle. Now, where AV node is present, just below SA node, here at the junction of auricular and at the junction of auricle and ventricle, at the, you can say, at the base of tricuspid wall. Here is a tricuspid wall because this is right AV aperture, and at the right AV aperture there is a guarding wall which is called tricuspid wall. So at the base of tricuspid wall, at the base of, you can say, interauricular septum, here another such nodular tissue is present which is called as AV node. So auriculoventricular node or atrioventricular node, which is located at the posterior border of interauricular septum, just above the ventricles. So here in this diagram, this is also represented that the SA node is connected with AV node by number of such loops. So there are loops of fibers which connect AV node and SA node together. From AV node arises a bundle of nerve fibers which is called bundle of His. So from AV node downward in the wall of ventricle arises a bundle of His. This bundle of His passes through interventricular septum. So bundle of His pass downward, then divide into two branches, one left branch, one right branch. Right branch is passed to the wall of right ventricle, and left branch passes in the wall of left ventricle. So this bundle is a bundle of nerve fiber arising from AV node. It is referred as bundle of His. This bundle passes down in the interventricular septum and divides into two branches, one going to each ventricle. Within the myocardium of the ventricle, that means within the wall of the ventricle, the branches break up into number of fine capillaries. You can see in the diagram, the blue color capillaries are shown, these fine branches. That means each bundle branch then divides into number of fine branches, or you can say network of fine branches, which is known as Purkinje fibers or fibers of Purkinje. Here they are shown in blue color in the diagram. So Purkinje fiber. These fibers are larger in diameter than the ordinary cardiac muscles fiber. Ordinary cardiac muscle fiber uh, has some thin fibers, but these are somewhat larger in diameter and they contain more glycogen. They store more glycogen. This impulse are transmitted by Purkinje fiber throughout the ventricular wall, causing the contraction of the muscles. The muscles of both auricle contract simultaneously. Likewise, the muscles of ventricle also contract simultaneously. So, in this diagram, we can see how the pulse is, you can say, generated. Impulse is generated through SA node, then it is passed throughout the wall of auricle, then it is transmitted to AV node through this, you can say, loops. From AV node, it is then passed down to bundle of His. Then bundle of His passes into both branches, and then from respective branch, the impulse is transmitted into the wall of ventricle, and hence the wall of ventricle contracts. So in this animation, we can clearly see the impulse of contraction is passing. Firstly, it is generated from SA node, then it passes down into AV node, then from AV node it passes into bundle of His, from bundle of His it passes down into the ventricular wall, and the contraction of wall, ventricular wall takes place. So likewise, we can say the working of heart starts with the contraction of auricle. That means the impulse of contraction is generated in SA node. From SA node, this impulse is transmitted to both auricle, causing auricular contraction. Then this impulse through the loops which connect SA node and AV node. Through these loops, the impulse is passed down to AV node. From AV node, the impulse is then conducted downward by bundle of His. And bundle of His passing through interventricular septum, it carries this impulse up to the ventricular wall, and the Purkinje fibers arising from bundle of His, these Purkinje fiber, they transmit this impulse of contraction to the wall of ventricle, and hence resulting into the contraction of ventricle. So in this way, heart works. That means beating of heart takes place. So auricular contraction, then ventricular contraction, and these events, they occur during every heartbeat. So auricular and ventricular contraction, they occurs during every heartbeat. So this is all regarding the conducting tissues of the heart and pacemaker of the heart.